Hello everyone, in this video we'll install a customly compiled Linux distribution to USB flash drive. So without further ado, let's get started. So I'm going to my desktop, and here I just want to say git clone and https and github.com, then my username and my customly compiled Linux distribution called Monkey See, Monkey Do Linux. So this is the BusyBox distribution, BusyBox-based distribution with glibc, with some networking, with some firmware for Wi-Fi, not for all available things, but those drivers that my hardware, both my laptops, involve. And yeah, basically we are going to install that. Okay, so let's go into the repository, and so here we have two essential folders. The EFI folder will go to the ESP partition, so-called, and the root folder will go to where the root file system for our Linux distribution is going to reside. You can have a look at README just to get an idea of what you can do with this stuff. And I've been covering the entire process of how to build this Linux distribution absolutely from scratch within the series, which this video is part of. So yeah, but in this video we are only going to install things to the USB flash drive. Yeah, so let's do sudo fdisk -l to list all of the devices that we have. And you see like this dev sda1, and we already have the 100 megabytes EFI system, and dev sda2 and 1.8 gigs, and that's the Linux file system. So that's eventually that's how the USB flash drive that we're supposed to be preparing in this video is going to look like. And I actually already have everything been installed and tested before the video, but I will now ruin everything and just partition the USB flash drive from scratch, and then I would be formatting it, like making file system, and then I would be providing things necessarily needed to make this installation actually working. So without further ado, let's get straight into it. So I can say, yeah, the first thing probably I just need to make sure that I probably have it mounted now at the media CMK, yeah, and this is the UUID. Yeah, I actually already have it mounted, so that's not what we go in for. So I need to unmount this USB drive first. So I say sudo umount, and I'm doing this media CMK and this stuff. Okay, got this unmounted now, and yeah, let's do sudo and fdisk dev sda. And we are getting into the command prompt from the fdisk, right? So here, let's say type M for help. So we want to create an empty GPT partition first. So we are going to make in the USB flash drive the bootable one, assuming the UEFI firmware. So it's not for legacy BIOS, that's just for the UEFI firmware, because doing this for legacy BIOS is quite simple, but the UEFI is a little bit, well, it's not more complicated, but it's a bit newer, so I just really want to cover that one. So I type G to create the GPT partition. So that's the first thing to do. And then I want to type N to create the new partition. So the default partition number is 1. And the first partition starts with the sector 2048 as default, so let it be like that. And then I can say plus 100 megabytes. So that's the default size for the ESP partition where the EFI folder will reside. Well, essentially, they're needed, not much needed there. Like in my case, maybe up to 10 megabytes only. But if you try to format to FAT32, the small size, it would be given some warning. So, well, if you have enough space on the USB flash drive on the hard drive, so the 100 megs is just the default minimum to set up. So I just say OK. And it has the system, it has the VFAT signature. Well, we could have leave this because we would still give it a VFAT signature. But since I really want to go like from scratch for everything, do I want to remove? Yes, I want to remove the signature. Okay. And then I want to say again U and partition number 2, and starting from the last block where the 100 megs ended and up to the very end of the USB flash drive. And it has the X3 signature. Well, interesting. Actually, has been converted, making the X4. Well, that's a bit strange, but doesn't matter. Yeah, I want to remove the signature anyway. And now, another important thing to do is to adjust the types of the partition. So I say T. I want to change the type for the partition number 1, and just L to list all the possible partitions. So you see, like 1 is EFI. So quit from here. And I say 1, and it tells me that the first partition changed from Linux file system, which is default 1, to the EFI system. And the second partition is Linux file system by default, so we don't really need to change anything there. So now I can just say write, and it just creates 2 partitions on my USB flash drive. So let's do sudo fdisk minus L one more time. You see, like we have, well, actually nothing changed so far. Yeah, but we've just petitioned the USB flash drive from scratch, and we cannot deal with it just as is for now because it's not formatted yet. So we need to format these partitions. And in order to do that, I can do the following. So I can say sudo mkfs.fat-f32 and dev sda1. So we make sda1, that would be the ESP the ESP boot partition with EFI executable files. So we done that. So now I say sudo mkfs.ext4 and dev sda2. For those who like the swap partition, if you want to use that, if you want your Linux kernel to be able to be using the swap partition, you can also create one swap partition, swap it on, but that's not essential. On my latest Linux Mint installation, I don't even have the swap partition at all. Yeah, so that's sort of a not really necessarily needed that much. Okay, so now I should already be capable of mounting my partitions to the file system that I have. So it's like it's created in UUID BEA24F06, etc., etc., etc. So let's just do some mounts now. And I just want to list the media, CMK, whatever is there. So there is nothing there. So well, let me just I could have just mounted manually, but let me unplug the USB flash drive and plug it back again so that it just mounts it automatically. Okay. Now, if I list this again, it already gives me the mount point that it has just created automatically. So it's currently empty, lost plus found. I just need to get rid of this. So if I just cd there to media, this stuff, list sudo rm minus recursively and forcingly delete the lost plus found. So no, nothing there. Okay. Great. So, but that's just the SDA2 partition has been mounted, but we didn't yet mount the SDA1 partition. So to do this, I need to do this explicitly. I say sudo mount and dev SDA1. I want to mount to the mount folder, which is also available. And if I now go to mount here, I have it's empty here, but we have the SDA1 partition mounted to the mount folder and the SDA2 partition mounted to media, CodeMonkeyKing, that's the username, and this BE824, etc., 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 etc. Right? So now let's go back to home, CMK desktop, monkey see, monkey do Linux. And here we have the script called hdd.sh. So essentially what this script does, let me just open this script first, probably. So hdd shell. So it updates the init.ramfs image that is going to be starting first before the switch to the root partition would happen. So we need to the purpose of the init.ramfs is to find the partition where the root file system actually resides and mount that, and then we can switch there, and then we do all the initialization from scratch again. So so far we have been living within the init.ramfs entirely, so all the tutorials I've been making so far, so we never left the init.ramfs because our file system has been living in the random access memory, has never been residing on the drive. So it was like in the root.cpu.gz archive, but again, that archive has been unpacked, being loaded into RAM and working there once the system is reboot. Once the system reboots, the changes are not saved, and that archive just gets loaded again every time again, but you cannot make any changes to this. So that's the RAMFS. So so far, we had the init script under the monkey see, monkey do Linux that didn't care about switching to the root file system. But starting from this particular stage, I actually added another init script. So now we have two init scripts. One init script resides in the init.ramfs, and another init script resides in the actual ROOTFS. So probably before showing you this, I just want to, so let's go to, so root is what is supposed to be copied to the dev SDA2 where the root file system is going to reside. So here, let me just show you the init. So eventually we would switch in here and we will mount the temporary file systems, we'll set up the permissions and execute as bin init. So this is the main init that would be running when we already switch to when we switch root to the actual root that resides on dev SDA2. But before that, we will run, load into the init.ramfs, and that would have another init file like this, but a bit different. So, but we need to generate that first, and also we need to know where exactly would the our actual root file system reside, and we need to manually adjust all the paths to that partition where it's needed. So, again, I'm going back to hdd shell script. Just really want to show you all the details. So what we do here, well, essentially, we download the ISO from the monkey see, monkey do Linux downloads, and that ISO is quite similar to the root file system that I've just been demonstrating. Well, it's a little bit different, but generally very similar to that one. So we mount the ISO, and then we do. We are going to creating the root. We extracting everything from the ISO to the root, and then user is prompted to specify the device where the root file system resides. So, for instance, like on the dev SDA2, that's where we're supposed to be copying our root file system. So I will mention that, and also the boot delay. So the problem is with if you boot from the hard drive, it gets mounted. It's available under the /dev on Linux. So the device, the hard drive device is being initialized instantly, but it might take a couple of seconds for the USB flash drive to get initialized. Hence the delay, because if we try to mount it instantly, it's not yet been initialized, so it cannot be mounted. So hence there would be the error, and the system would not be able to switch to the actual root file system because the target hard drive to look for the root file system at would not yet be initialized and mounted respectively. So here I'm creating the custom init for the init.ramfs and I would be that. So what's happening here is quite similar to what we're doing in the main, root that resides in the root file system, but it's a little bit different because here we use I execute the switch root. So I'm essentially what I'm doing here. I'm creating the mount directory under the INITRAMFS. I then mount the device that user enters, well, let's say dev-sde2, to mount. And when in the INITRAMFS, under the mount, we have the dev-sde2, or essentially our physical root file system, been mounted to, we can then execute the switch root command using exec to make sure that this switch root will be running as the PID1. PID1 is special in Linux. You cannot kill PID1, so that's essential for things to work. So we're switching the root to whatever is at the mount, and we're using the init script under the new file system. So this is pointing to the new init. And also don't forget to make that init executable, the one that we've just created. Otherwise, it's not going to get executed. And after this, we pack the INITRAMFS back. So essentially here we are updating the INITRAMFS, because you might have the, so why to do this, you might have the name of the target device where your root file system is going to reside, not dev-sda2, but dev-sda3, sda4, or hda3, or hda2, or nvme 01, p1, or p2, whatever name. So whatever name you are sure that there would be your actual physical device, you need to specify that. And again, if that is the USB flash drive, then you also need to specify the delay greater than 0, because yes, otherwise it's just not going to be seen. So if you're using the hard drive, the delay might be set to basically to 0, just to speed up the boot. That's it. But yeah, for USB flash drive, it's better to wait a little bit. And eventually what happens, so it just copies this newly created, newly updated INITRAMFS.cpiu.gz to the root, and under the boot and to the root cpiu.gz. That's where the GRUB configuration file would be looking for when it gets, when the script under the GRUB CFG would get executed. So enough words, I just escape from here, and I just run this hdd shell script. Okay, so I'm now downloading the ISO file from Monkey Linux release, yeah. So that's the ISO that you can obtain not just by downloading, you can also compile it from scratch, and I've been walking through the commands under the build script. Okay, so enter device path for where the ROOTFS resides. So our ROOTFS is going to reside on the USB flash drive under the dev/sda2 partition. So I say /dev/sda2. Okay, and how much to wait? 5 seconds would be enough. And it has just updated things. So again, if you want something else, if it's not in dev/sda2, then yeah, you just put whatever path is relevant to you. Now, if I go to the root, and if I go to boot, here we have this root.cpiu.gz, which has just been updated by the hdd.sh script that we've just run, right? So beta image is just the kernel image. So now the GRUB configuration, that's another important thing. So we are going to the GRUB folder under the ROOTFS that we're supposed to be copying. So go in there and see what we got here, GRUB CFG. Well, probably, yeah, I guess the more proper way of doing things is actually first to copy things to the physical device and then do the corrections, because, yeah, it doesn't make sense to make this under the repository. So let me first actually copy things. So, yeah, I just say sudo cp-r recursively root, and everything that is within the root to media, code monkey key, and my USB flash drive SDA2. So I just copied the root there. So let me quickly check whether that's actually the case. So okay, now we have the root file system being available at my USB flash drive. And then I just do, so list EFI. Yeah, now I want to say sudo cp-r EFI folder to mount, and I just call the folder EFI. So this is similar to what grub install command would actually do, and you could have used the grub install, but since, let's say you're booting from the ISO that you've previously burned to the USB flash drive and you're trying to install the real hard drive on your laptop, you don't have any other system that the live Monkey Linux image. In that case, you don't have grub, yeah? So, but you still have an option to install things. So hopefully that makes sense. That's the reason why I have everything sort of pre-installed onto the repository for the ease of use, for the sake of the matter like easiness of usage. Okay, so now let's first go to dev SDA2, which is mounted to in here. And here we go into boot. So we are on the USB flash drive now. And I'm going to grub. And here we have the grub CFG. Now probably need sudo to open this to make changes. So sudo VICI is the text editor I've written. Sudo VICI and grub CFG. Yes. So let's have a look what we got here. So the configurations are all good. So it would be looking for the Linux kernel under the boot beta image and the INITRAMFS under the boot root.cpio.gz. But where is this boot? So what is the partition for this boot to look for? And this line is responsible for this. So we say set root, and I say hd0. Well, in my case, that's my case. So if I just plug in the my USB flash drive and I say boot to the UEFI shell or to the GRUB shell, if I list all the devices available, it tells me that my USB flash drive is actually hd0. And currently it has two partitions, GPT1 and GPT2, because we've been formatting this to GPT. So things like SDA, it's already the Linux specific step, but when there is no Linux, when there's just a pure UEFI firmware environment there, we only have the like HD0, which is the identifier for the hard drive, and then the type of the partition that is available on the hard drive, which is the GPT, because we're dealing with the UEFI system. So GPT1 and GPT2. So GPT1 is dev SDA1, let's say, and GPT2 is dev SDA2. So since our root file system resides on dev SDA2, we need to set root to HD0 GPT2. Okay, so hopefully that makes sense. Yeah, because otherwise this path would make no sense to the grub bootloader to search for the actual beta image, Linux kernel image, and the INITRAMFS. It would just not find one, right? So the rest are just the configurations we've been walking through many times earlier. And just to make sure that the fonts would be loaded and all this stuff, the root itself has, like under the root, I have everything installed there as if I've installed grub there previously. Actually, I did. So, for instance, if I just list the, fonts, there is the Unicode PF2 font. If I list the x86 EFI, here are the modules that I used under the grub. So everything is there. So yeah, so you need to make sure that the set root under the grub CFG on the root file system points exactly to the partition, to the GPT partition where the root file system resides. But that's not yet the end. And another thing is the following. So I'm going now to the mount, and here we should have the EFI folder, and we do. And I cd to the EFI. And here we have boot, which is essentially bootx64.efi is the UEFI shell, but it's configured the way so it just runs the GRUB bootloader. But it can also be used like just the pure UEFI shell as well. So MMX64 is something regards memory. I'm not quite sure. FBX64 is probably related to frame buff. Again, not really that sure. And the Ubuntu folder is the boot entry created by the grub install command. Here is the problem. I tried to rename this Ubuntu to something else, but in that case, my when grub loads, it just loads to the grub shell, even though the grub CFG, another grub CFG, I will now show which one grub CFG, is already specified, but it's not seen. It just goes into the grub shell and spend 3 days debugging this. I couldn't bypass this other thing, so I just keep the things as is. I just keep the boot entry called Ubuntu, and that just works well enough. Even on my Linux Mint, the boot entry is actually named Ubuntu, not the Linux Mint. So not quite sure. And also, we will need to, since this is not the real Ubuntu, but my customly compiled Linux distribution, we will need to disable the secure root. But that I will show you this when we would be booting things on the real hardware, right? For now, we just cd into the Ubuntu, which is the entry, the boot entry, and again, there is no file as shim-x64.efi, which is responsible for assigning the boot for the secure boot. So we have just the grub x64.efi, which is the EFI version of the grub bootloader, and this grub CFG nearby. It just essentially it runs the command. Let me cat this grub. This grub runs the command. The last file, the last line is config file and path to where the grub CFG actually resides. And we need to find that. And here we are not setting the root as like hd0 GPT2, but instead we are using the UUID to search, and that would be assigned to the root. So we need actually to change this a little bit. So if I say sudo VICI and grub CFG, so the UUID currently available here is from the previous installation. So what I need here is I need to replace this with the newly created one, and I just write the changes and I quit from here. And if I count this again, so see, like the changes has been made. So now this is the new UUID, that is corresponding to the dev SDA2 or HD0 GPT2 on my USB flash drive. Now, with these things being set up, we should now be capable of actually booting into the Monkey C, Monkey 2 Linux on the real hardware when I reboot the computer the way, so that it first runs the INITRAMFS, and then it would find the partition, this dev SDA2 partition, and it would switch the root there. It would then run the init second time, not the init. So first it runs the init from the INITRAMFS, then it runs the init from the actual root file system. It would initialize everything, would then run the sbin init, which is a BusyBox init system, and then we will fall into the shell, and from there we would be capable of executing commands. Essentially, our Linux would be installed by that time. But before that, we'll now restart things. I'll now put the camera to show the real screen on my laptop, and I'll show you what exactly do we need to do under the UEFI firmware settings to make sure everything boots properly. So bear with me. Okay, so this is the moment of truth. So I'm starting the laptop, and first I will go into my UEFI firmware settings by pressing F2. Okay. So here I already have the secure boot being disabled, as you can see, but this might be different across different UEFI firmware configuration applications. So usually if I do just create this supervisor password and confirm it, in this case, I can either enable or disable the secure boot. So by default, if you have the factory settings, you would most likely have things like all the boot settings being erased and the factory settings being enabled. But in this case, if I just save this, exit, and reboot, it would fail to load the specific boot entry. So we have two Ubuntus here. The first Ubuntu is the one that we've just created. The second one is my Linux Mint system. So, I can probably show you how this is not going to work this way, just to troubleshoot some potential issues you might have encountered when you try to boot, but maybe you forgot to switch off the secure boot, and sometimes it just turns the computer off, so I just need to turn it on back. Okay, so now if I try to run this upper Ubuntu says just reset systems and nothing happens, well, that's because it's not signed, and secure boot simply prevents me from loading the particular system because it's not signed. Now I'm entering the my UEFI settings here. And yes, again, I can just say the secure boot to disabled, and I can remove my supervisor password by typing it again. So it's no longer going to ask me for a supervisor password anymore. So exit and save changes. And now when I press F12 again, yeah, it should bring me to the menu. And now if I hit this Ubuntu, so what happens now, the configuration file on the devsda1 is looking for the GRUB configuration at the devsda2 and successfully runs it using the config file command. Now the INITRAMFS is loading, and once it's done, once it mounted the devsda2, it's then waiting to USB to get activated so that it can mount the devsda2 on my USB flash drive to the actual mounting point, and then it switches there using the switch root from BusyBox. And already here, so I'm now in the monkey2 folder, so let's cd to the root. So this is the root. The directories like dev, proc and sys has been created, so just show you the init script here. So it just creates the home and monkey2 directory if it's not there. It then creates a dev, proc and sys if it's not there. Okay, then it mounts all the file systems. Then it sets up the permissions properly. So this is the important permission for the sudo is configuration file for the sudo command. So otherwise it's not going to work simply. Then creates the proper permissions for the home folder, for the monkey2 folder, and eventually executes the BusyBox has been in it. So this has been described earlier. Now let me go back to the home directory and monkey2. So nothing here. So probably the ash history. No, not even the. Yeah, ash history is already there, so we can see what is in the ash history. Yeah. So the commands there I'll be running. So this is actually the second time I'm running this. The first one video wasn't recorded properly. Okay. So yeah. Now let me show the following thing. So there is the so initially the system was trying to connect to the network on boot, but I've disabled this later. It's still on the cards on the live ISO, but now if you want to connect to the network using the Ethernet cable, you need to run the command Ethernet shell. It's available system-wide, so let me show you this. I'm going to go into living under the bin Ethernet shell. It's not going to be. Let's just hold on a sec. Let me adjust the camera a little bit. We're not going to use this now because I don't have the Ethernet cable being plugged in, although it's possible as well. What we're supposed to be using is the Wi-Fi. So if we have a look at the Wi-Fi shell under the bin, then here you see like you can enter the SSID and the password. So this assumes the WPA encryption, and then it would run the WP passphrase to encrypt the password. It would store this to the Wi-Fi configuration. It would then try to connect to the specific SSID, and then it would try to obtain the IP address automatically by running the UDHCPC. So let me quickly show you how this is supposed to be working. So I'm just running the Wi-Fi shell, and it tries to connect to the internet, and yeah, it even obtains the IP address. If now we run ls, we have the Wi-Fi conf file being created. So like for instance, I can say cat Wi-Fi conf. So here is the bottom line PSK. That's the encryption of the password, the encrypted version of the password that is actually being sent to the access point. So yeah, hopefully that makes sense. Now we can actually start doing some HTTP requests. So for instance, I can do WGET, and first I want to output things to console, HTTPS And let's go to example.com. And here we go. And we get the HTML response. So internet is working nicely. We can also store this as just as the file called index.html. So here is the file index.html. We can cat this to the screen and see what is there. And now, yeah, the most satisfying thing is that if I now do sudo reboot, all the files that we've just created would still be there after I reboot the system. Okay, so again, like now it just goes automatically, and yeah, I'm going to my repository, and yeah, same thing, same steps again. And now if I do ls, I still have these two files being available. Yeah, it's a little bit unclear whether it just made them executable. So what? Ls minus L index HTML. Yeah, for some reason it makes them executable. Well, this is a little bit strange, to be honest. Yeah, I still need to figure out why in particular is that actually happening. So yeah, but generally we have the proof of that. This is the actual root file system. It's not the INITRAMFS anymore. Well, okay, guys, that's it from my side. Thanks for watching. Hope you find something useful within this video. And yeah, see you in the next one. Until then, and cheers.